right, the last lesson of chapter 1 is 1.6 that now goes into pairs of angles. So in the last lesson, we talked a lot about different angles, but now they're going to deal with pairs of angles. So in this one, at the beginning, they would like you to explore, which I don't think it's necessarily a bad I don't think this is a bad exploration. So if you can pause it here, go ahead and just see if you can come up with those different numbers. Okay, hopefully you paused it. Now, the exploration, what they're really trying to get you to notice is, in a way, what is the relationship? So, for instance, x. Do you see how the x in the 108 fall on a straight line? They were just trying to get you to see if you would do 180 minus 108 to get the value of x, which is 72. So ultimately, I mean, right now, I'm not super concerned about do you get 72, but they wanted you to explore the relationship. That relationship right there is called a linear pair. Oftentimes you'll see me abbreviate this as LP because it's one of the most commonly, there's two we use a lot. Linear pair is one of the two. So in a linear pair angle, there's a couple things that have to be true. One, you have to be adjacent. So adjacent angles are angles that are side by side. So for instance, let's say we have angle 1, angle 2. So these are called adjacent angles. So let's just write this down. You can't even write adjacent. E-N-T, adjacent angles. Now, oftentimes we don't talk a lot about adjacent angles by themselves, but adjacent comes in to other definitions. So this is adjacent, but it's not a linear pair because it doesn't meet requirement 2. Requirement 2 means that they need to fall on a straight line. So if I were to take that same kind of picture, so let's do, here's angle 1, so see how it's very similar to that picture. But instead of putting angle 2 right here, I'd have to go like this. Angle 2. That makes them a linear pair, okay? So if you notice from the 108, X would be a linear pair, and so would Z. Z would also be a linear pair, so we could subtract from 180 and we'd also get 72. So if you want to write here for adjacent, I just like to say side by side. Now, the one other thing that you do have to remember with adjacent is they have to share a vertex. What I mean is they cannot do this. You ready? So maybe don't write this on your paper. Here's angle 1. You can't do this. Do you see how those are side by side? But notice here's the vertex and here's the vertex. Those are not adjacent. Those are just two random goofy looking angles, maybe both acute, but those don't have a name to them. So they have to share a vertex and they have to be side by side. So if we want to draw angle 1, angle 2 in there, notice they share a vertex and they share a ray, a common ray there. They're side by side. All right. So again, adjacent is just kind of like a small little vocabulary word. So I'm not going to put a star by that one. But the next one, do you notice Z and X? Do you see how they're across from each other and they're the same degree? Those are called vertical. So vertical angles are basically like, I always say like, so they're two non-adjacent. So they cannot be adjacent because they're going to be across from each other. So two non-adjacent angles. We can say across from each other. Now there is one other minor detail we're going to want to add in there. Okay. So not only do they have to be across from each other, so just watch for a second. Okay, here's one, and then so here's angle 1. Do you see how they form they have they're not adjacent, so there's a gap there. But do you see how they are across from each other? But do you see how their lines are not straight? Do you see how this one kind of has a bend to it? So vertical angles have to be formed with two straight lines. Now, these are not the book's definitions, so if you'd like to look these up in the book, you are more than welcome to. But if you notice up here, Y and 108, do you see how they're across from each other and they have crossing lines? Those would also be vertical. So are X and Z. Those are also vertical. So vertical angles, not only will you notice that they're across from each other, but they're also equal. So vertical, the easiest thing to do is just draw yourself two straight lines. And then it doesn't matter which way you go. You can either go left to right or top to bottom. It doesn't make any difference. But those would be vertical. And that is the other pair that's also extremely common. Those two are probably the most common types of angles you'll see. Now, you might have worked your way around and tried to find the other angles here. Sometimes it's difficult for students to find V and W, but what you're supposed to notice, and they really don't do a good job of explaining this, is it's regular, which means that these sides would be equal. So it's isosceles. So if this is isosceles, then W would also be 72, because in an isosceles triangle, so if you have an isosceles triangle, these base angles right here are congruent. So this would be 72. And then if you use triangle sum theorem, which means that the three angles in a triangle have to total 180. If we subtract 72 twice, because it's the two bottom, so if we subtract off 72 twice, that means, oops, sorry, I didn't realize there's a little glare on my screen sometimes if I'm up too high. Notice then this top angle would be 36. So if you did not get V and W, that's probably not the end of the world, but it really was more important for you to see if you could get X, Y, Z. Those are the three that they were kind of really wanting you to focus on. Now, if you notice on our chart here, we have two more boxes, and you probably, gosh, I can't pick up my papers. Sorry. There's two more boxes, and you probably know these. You just might be forgetting about it. Remember, the lesson is on angle pairs. So if you're going to put angles together, what are some other names that we have? And two other names that we have are complement and supplement. So complementary angles and supplementary. All right, so quick fill those in and see if you can remember which one is which. So if we were there together, I'd be asking you, but since I'm alone, complement is add to 90. But remember, it's two angles. It cannot be three. It has to be two. So two angles that add to 90. And so supplement is the same, two angles, just going to kind of abbreviate there, that add to 90. Now, they don't have to be adjacent. I'm going to draw you, for complement, I'll draw you each picture. Let's say they're adjacent. So clearly they have to total 90, right? So here's my 90. Now, they don't have to be even remotely even. Like this could be 20 and this could be 70. But do you see how together they total 90? Now, they could also not touch. So this would be non-adjacent complement. So let's say you have like a 40-degree angle here. You might have a 50-degree angle over here. But together, they're still 90. So this would be considered adjacent. This is not adjacent. You can have the same thing with supplementary. If they're adjacent, why did I put 90? Supplementary is 180. Hopefully you were thinking, Mrs. Twig, you made a mistake. Sometimes I get going and I don't even think about it until I look back. So yeah, supplement's 180. They're not going to be the same. So supplement, you would draw a line because it's 180, and then you would just put your angles on here. So if they're adjacent, they'd be side by side. So maybe this is 100 and this is 80. I don't know, I'm just trying to make it easy. If they're not adjacent, maybe this is 110 and then this one is 70. Again, just trying to make it easy. I'm not trying to pick crazy numbers here, but notice what my total is and what my total is. So complement is 90, supplement is 180. All right. Okay. Couple more questions. Going to go kind of quick here. Let's see. Hopefully I won't make too many mistakes. Now they're just asking you to pick them out of a picture. So if you want to pause the video here, it wouldn't be bad to try these on your own and see if you get them right. Okay, hopefully you paused them. Complementary, remember, just so we're reviewing, means you add to 90. So clearly it cannot be this. So you might just want a quick check. What's 37 plus 53? And it is 90. So then you just need to say this bottom angle, so CAB. And remember, yes, you can reverse the outer two, but the A has to be in the middle. And we need to say this angle, so RST. So they just want you to name them. All right, how about supplement? 180. So now you look at this and you're like, which one's total 180? Well, clearly I can tell it's not these two because they don't fall in a straight line. So 127 and 53, that would be 180. So I need this top angle, DAC, top, and this one, RST. Again, really, really be careful here with your angles. Now, technically, this angle right here, I could have probably just said angle S because there would be no confusion on the location. But angle A, you'd have to be specific. So again, watch that. Okay, adjacent. Remember, adjacent just means they have to share a vertex and they have to be touching. Well, clearly there's nothing in this picture. So it would have to be this top angle with this bottom angle. So top angle, there's the top, and the bottom. Now remember, you can start with B or you can start with C. It really doesn't make a difference. So you can interchange those two letters if you want. All right, now they're just asking you to describe what these are. So if you look at like 1 and 5, they just want you to pick the name. So again, if you want to pause it here and just kind of quick write down these 4, that'd be great. Okay, 1 and 5, notice they're across from each other, so we say vertical. Again, I use those abbreviations, vertical and linear pair, because they're so common. 4 and 5, notice 4 and 5. Yes, 4 and 5 are adjacent. I do not disagree. But not only are they adjacent, but they fall on a straight line, so I also call them a linear pair. 2 and 4. Good gosh. They're across from each other, but their lines are not straight. Do you see that? So I would say none. There's nothing in common. All right, 3 and 5. Definitely would say they're adjacent. They almost look like they're complementary, like that they might total 90, but we don't know for sure, so we're not going to assume that. So I guess I would just say adjacent and be done. All right, number 9, they're just trying to give you some application of complement and supplement. I mean, really, you don't need to look at a ton of this. It's just trying to talk about, you know, like a net. Like I think about Grady has one of these in the backyard that's like a baseball net, you know. I mean, this one's a soccer, but Grady has one for baseball. They just want you to find the value of X. So these two angles are not equal because this one's obtuse and acute. But if we add them together, so if we add 4x and x, and if we add 8 and 2, that's going to total 180. So we can clearly add this together. So we're going to do subtract 10. And then 170 divided by 5, I don't know off the top of my head, is 34. And because they want the value of x, then we're done. We don't have to like plug it back in. So we're just done. Okay? All right. Almost done. Number 10. Notice number 9 was supplementary, so they want to give you an example of complement, but this one just isn't really an application. There's no picture, so notice they're just telling you that these are complementary. So see how LMN is the first, PQR is the second. So all they're telling you is that these are going to add to 90. So let's just do that. 4x plus 9x. Minus 2 plus 1, set it to 90, solve it. Let's move the 1 over, and then 91 divided by 13. Now, am I going to be done? No. See, in this one, they want PQR. Where over here, remember, they just wanted X. So you just have to be careful on, do you get to stop or do you have to continue? So PQR is this one. So I just have to plug it back in. So 9 times 7 would be what? 63 plus 1, so 64. And that's my answer. Okay? All right, just a couple questions to go here. Notice once again, whenever they give you a supplement, they always like to give you a complement, just kind of like so you can practice one of each, which, you know, is good. They're just trying to change it up a little bit. All right, it says 2 angles that are supplement. So right now I'm thinking to myself, it's 2 angles that are going to add to 180. I just got to figure out what they are. The measure of one angle is 5 times the measure of the other angle. Find the measure of each. Okay, let me read that again. The measure of one angle, so let's just say this angle, is 5 times the measure. So 5 times the measure of the other. Well, I don't know what this angle is. Why don't I just call this X? Then wouldn't this be 5 times X? And then couldn't I just add those together? 5X plus X would be 6X. And then if I divide, I get 30. So that means one of the angles is 30. Now I can either plug 30 back in, or I can just take 180 minus 30. And there's my 2 angles. Now notice this one is 5 times it. So I know I've done it right. So why don't you try number 12? Now you know this one's a complement, so you do have to change this part, but it's going to be very similar. So why don't you pause it here and try it? All right, I wrote down 20 and 70, so hopefully I did this right. I know in yesterday's video I think I had a mistake in mine, so hopefully this one's right. If you got that correct, why don't you move on and try the next one, the last one. So let's just go through this. We've got complement, which is 90. So it says an angle, I'm going to call it this one, is 10 more than 3 times this one. So I'm going to call this X. This would be 3X. So that's going to be 10 plus 4X is equal to 90. If I subtract the 10, if I divide by 4, so there's my one angle, there's the 20, and then I really could just go 90 minus 20 to get the other angle. So, yep, it looks like I did them correct. Okay? Now, this really is the main part of the lesson. Like, that's really kind of where the lesson ends right there. But like anything, we always want to give you a little bit of a challenge. So if you're feeling pretty good and you've got the time, go ahead and let's try number 13. Now in number 13, do you notice that these are a linear pair? Do you notice these are vertical? So in number 13, essentially, you can kind of pick which method you want to do here. Now, I can tell you there's an easier path and a more difficult path. So let me give you the 2 options. So option 1 is you're going to use linear pair. So you're either going to go like this, or you're going to go like this. Option 2 is vertical. Now we can't go this way because we don't really have anything here. Or we could go like this. 180 minus 50 would be 130. So I guess I could go this way. But let me show you just real quick. If we go with vertical, let's say we do this path. So we do that. If we do x plus 2y equals 50, how are we going to solve that? I mean, that's going to be challenging, right? So I don't really want to do that. So I'm going to erase that. So let's come up with a different plan. How about we try the linear pair? Now, I could do this. Just realize I could. It's going to be challenging, but I could do it. Linear pair. I don't want to pick this because I'm essentially going to be practically in the same boat as I am here. What if I go this way? Now, I know this is going to look strange, so just bear with me. X plus 2y plus this one. So if I add these together, that's going to total 180. All right, let's put these together. What's x plus x? What's 2y minus 2y? Ooh, how nice was that? Do you see how they canceled? Now, if you divide by 2, you get x to be 90. Do you see how sometimes you got to kind of try different things to see what would work? Sometimes your first option could be done, but it might be quite harder. So I say you go with the easier one. Now, if this is 50, then that means this is 50. So what I'm thinking about doing, so I have my x. What I'm thinking about doing is taking that equation, 50 equals x plus 2y. Now just plug 90 in. So 90 plus 2y. If I subtract the 90, and if I divide off the 2, now it's okay that the y value is negative. That's okay. Sometimes people look at that and they get all confused or flustered because they're like, why is it negative? But watch if I use my calculator here, and let's say I use this, which x is 90 plus 2 times negative 20. Notice I better get the 50 back, and I do. If I do linear pair, 180 minus 50, that makes this 130. Watch if I plug in 90 minus 2 times the y value. Will I get 130 back? And see how I do. So again, they're just trying to get you to use your geometric principles, so vertical, linear pair, and review your algebra skills. So once again, that was why on the first day, I had us review some of our algebra. Well, that concludes the last lesson of Chapter 1.